Hello everyone, welcome to today's webinar. My name is Kapil and I'm a part of marketing team here at EDB. I will be your host today for the session on develop cloud native apps on Kubernetes with Postgres. The speaker for today's session is Adam Wright, Senior Product Manager at EDB. Unfortunately, Adam could not attend today's live session due to a storm in the greater Boston area that resulted in a power outage. So today's session will be a pre-recorded session for about 45 minutes. We also have Chandan Krishna, who's the sales engineer at EDB, to answer any questions that you might have. The lines will be muted throughout the session. If you have a question, please feel free to submit it in the Q&A panel. Chandan will address the questions towards the end of the session. If we do not have enough time to answer all the questions, we'll follow up later with any attendees whose questions were not answered. Now, without further ado, let's get started with the session.
Hello everyone. Today we're going to talk about running PostgreSQL in Kubernetes and how it affects application developers. My name is Adam Wright. I'm the product manager for containers and Kubernetes, a combination that makes up our product offering, Cloud Native Postgres, and later in the year, a re-release of our Cloud Native BDR operator. You'll likely hear me reference my many years as a database consultant working directly with customers who are using Postgres. There's a different perspective today that can be taken with the cloud native approach, where the database is no longer a separate dependency deployed and managed in a completely different way than your application, with responsibility for deploying and managing falling on an entirely different team. So let's talk about this different approach. We are providing at EDB with our cloud native Postgres offering, and this allows you to deploy databases in the same way you deploy your container applications, with a set of advanced infrastructure features that you can leverage without needing to involve another team. In fact, the tools you need to bundle the database with your application are provided right out of the box. So on the agenda for today, we're going to talk about PostgreSQL when considering running databases in Kubernetes with the follow-on question, why EDB? We'll also talk about the declarative management of our Kubernetes objects, the CNP cluster, and how this enables flexibility with your application. We'll future-proof your deployment by running a Postgres cluster that can be deployed on private, public, and hybrid clouds with the same procedure. No need for operational runbooks depending on a different location context. With CNP deployments, Kubernetes objects such as services are created, and this really gives application developers flexibility to finally leverage all of the standbys of a cluster without having to have a DBA team vet and configure complex services with lots of operational overhead. Along those same lines, we'll talk about some of the advanced features that can be leveraged for your application requirements without having to be a Postgres expert. And knowing Postgres always helps, but being a system DBA is not required. And finally, when you're ready to get started with Postgres on Kubernetes, we'll point you to how you can get started with cloud native Postgres. All right, so you're deploying applications with containers, and there are many different choices for where you store data. Let's first cover why EDB over the other options available. At the end of the day, what's being deployed is still Postgres. Whatever abstraction layers there are, your data is still being stored and managed by Postgres, and EDB is the largest Postgres company with hundreds of technical staff dedicated to working on Postgres and the Postgres ecosystem. Not only can we patch the database and develop the advanced features that our customers need for the database, but we also have dedicated support staff around the globe, and we've been working with customers that have been pushing the limits in terms of scalability with Postgres for many years now. And more relevant to today's discussion, we've been supporting customers that have really been innovating in approaches to where applications get deployed, and subsequently where Postgres then gets deployed. So EDB is very invested in the Postgres community, lots of development for the Postgres project. Our team spans 350 plus experts, on all different levels of the community. You can see some of the well-known faces of the Postgres community down below on this slide. They have very important responsibilities for the Postgres ecosystem. Right, so this presentation is about developers leveraging cloud native Postgres through its rich feature set. The core technology of cloud native Postgres is the Kubernetes operator for EDB. So it's good that we have this foundation as we go forward here. So what does it take to be successful at developing a Kubernetes operator for Postgres? You need a team of experts in both Postgres and Kubernetes. And at EDB, we are heavily invested in Kubernetes now. We are the first and currently only dedicated Postgres company to become a Kubernetes certified service provider. We have a large number of technical team members who are certified in Kubernetes. The entire Kubernetes development staff at EDB is certified. The Kubernetes expertise, this all complements the previous data points where I talked about EDB Postgres expertise. EDB is also a silver member of the Cloud Native Computing Foundation. The Cloud Native development team at EDB performed 10 live demos in just 4 days at KubeCon Europe, just last month in early May. And if you're using OpenShift for your Kubernetes distribution, our operator, which is based on the primary standby architecture, is Red Hat certified for OpenShift. As mentioned, our BDR operator coming later in the year. And as we talk about, continuous integration, continuous development practices, you will see here at EDB that the cloud native team is leading with industry-leading modern development practices. These may be practices you're adopting yourself. In fact, we are releasing a new version of CMP every 2 weeks. So if there's a feature your application needs, you likely won't need to wait a year for, the next major version to be released. And just so we can ensure that there's no confusion, a quick recap of what's involved with our initial release. What are the tangible components of Cloud Native Postgres? Well, there's the Kubernetes operator with all the expertise for deploying and managing complex applications like Postgres high availability. There are also the operands, lightweight Docker container images for Postgres and EDB Postgres Advanced. The same operator can manage both database server types in different database versions. The only difference is the image name in your deployment manifest. And we've begun adding tools to the Cloud Native Postgres suite. Prior to going in production, you can run CMP bench to validate a subset of a Kubernetes environment for database workloads. These are deployed as Helm charts and allow you to validate storage and database performance with standard tools, FIO and PG Bench. A new plugin for kubectl is available for getting cluster status results targeted towards CMP users, with additional commands for performing various actions such as generating SSL certificates for your application to use for database authentication. We'll talk more about this later. All right, the main capabilities are to provide a platform that allows the entire lifecycle management of a Postgres database wherever your application needs to be deployed. And since Kubernetes is the de facto container orchestrator, then we can use the same operational procedures, whether it be in a public cloud with a Kubernetes distribution like OpenShift that can be deployed public or private, or just public only distributions like Microsoft Azure with Azure Kubernetes services. And if you're using the EDB Cloud Native Postgres operator to deploy Postgres, there is zero lock-in. The operator takes standard Postgres backups that are stored on an object store that you own and control. Cloud Native Postgres can bootstrap a new cluster from a backup. And this goes both ways, right? There's no reason you couldn't take a backup from Cloud Native Postgres and restore it to any PostgreSQL server of the same version. All right, so what makes EDB unique here? Using the Kubernetes operator by EDB, you can run PostgreSQL, the open source community database that EDB is a major contributor to. You can run EDB Postgres Advanced, and if you need production grade bidirectional replication where all nodes in the cluster accept writes, then later this year, our BDR operator will be an option for you. These are all technologies developed within EDB. Our backup client, Barman Cloud, an open source tool, which EDB is the maintainer for, and the HA components that are baked into the operator itself are designed and written by EDB staff. There is no need for us to go, hunting for projects in GitHubs, get this HA tool, let's get this backup tool and glue them together with an operator. We did not have to do that. At the end of the day, you get Postgres and Kubernetes expertise with cloud native Postgres. And while the operator is opinionated, you still have the flexibility with which EDB technologies best fit your use case. All right, so now that we have all that covered, let's go ahead and talk about Postgres with Kubernetes. So we touched on there being a number of different data store choices with Kubernetes, but is Postgres and cloud native Postgres a good fit? We asked this, because while we have customers running mission critical workloads in Kubernetes today, a large number of customers, prospects are proceeding cautiously, much like virtual machines. First came the application and then come the database. And if you're watching this webinar, you might just be trying to learn more about this as well to make an informed decision. And this is kind of how we see whether or not it's a fit. Maybe you're already running Postgres or looking at Postgres for new application development. If you're already doing that, then yeah, so Postgres is a Kubernetes friendly database. It's extremely lightweight. It doesn't try to be an entire operating system like some commercial database systems, developed early on at a different time. And then there are still advanced features that help with managing state, security, and the entire life cycle of the database. And for developers, Postgres has a rich set of data types. It's performant, and the most common programming languages have Postgres drivers and support by most ORMs. There is also flexibility for development practices, where you can write applications local with local deployments that, when using an operator like CNP, have a setup and deployment that is identical to production. So Postgres is a, Kubernetes-friendly database. And so then the decision really comes down to how much operations workload is acceptable. At the bottom, on the right-hand side, at the very bottom, we have the full VM deployment that gives you complete control from the Linux kernel to the database installation and maintenance. And then, going top to bottom, there's the DBaaS option that handles all operational aspects. And, where the provider has full responsibility and you have little responsibility from the operational perspective. And at the top, you have the Kubernetes operator that's kind of in the middle of those two. Your team, is controls, when deployments happen. You pick your Kubernetes distributions for those deployments. So you have some flexibility there, but it's still up to, your DevOps team to do deployments, how you do maintenance, those types of aspects. So you still get the database on demand for developers, no matter where you're deploying with cloud native Postgres, you have flexibility for where that can be deployed. All right, so Postgres, part of the reason it makes for a good cloud native database distribution, it has a rich set of data types to choose from. This makes it extremely easy for developers to enforce business rules. This is really important, for new application development when you're thinking about, going to Kubernetes. We bring this up really because, a lot of customers on their journey to databases on Kubernetes, start to explore whether to use a specialty database system or stick with a relational database for these new applications. You might look at whether or not to use a document database. So you have that choice in Postgres. There are elementary data types like character with fixed length or padded. Text for variable length characters. You can perform explicit typecasting in your applications or in Postgres server-side functions. There are several choices for storing numbers and ranges of integer data values. And these allow you to perfectly match, the numeric type to the business attribute you're applying this to. And then there are more specialty types, like Boolean for true, false, on, off. And those can be represented in different ways. Also, you have the choice of arrays, byte A for binary data, XML, JSON, JSON-B, which is really popular and relevant to the choice on, whether to do document or not, HStore for key value pairs, money data types, IP addresses, IPv4, IPv6, MAC addresses. These are all data type choices that you have for your application through Postgres. So you don't have to apply those rules for the data types in your application. And through the extension framework, you get more specialty data types like PostGIS. This not only allows you to store different data types and spatial data types like lines, points, polygons, multi-polygons, but then you also have geometry constructors. You can do topology relationships, distance relationships, and many other geometry functions. So at some point, you're going to likely have to work with data that has a spatial attribute. And PostGIS is a really great choice. It's just another attribute of the data and still allows for powerful calculations. So you don't need to pull the data across the wire into another system to process separately. And if you want to get started to try PostGIS, you could deploy with Cloud Native Postgres. And the only thing you need to do to add PostGIS is pull the image with the PostGIS tag. That same extension work that allows PostGIS to be a first-class citizen in the database can, also be used by your company. If you're doing low-level development in your company, you could develop an extension for Postgres that has a data type specific to your industry. And like PostGIS, it would still be a first-class citizen in the database. So here's kind of a visual of the document decision we're talking about. So along with these specialty database systems, you're evaluating whether or not to use document storage engines or use a relational database like Postgres. One of the powers of Postgres is that you have the choice of whether to do all document. This would be in the orange box there. Creating a table that stores nothing but JSON-B as the document format. Or you could use like HStore for key value pairs. So this is similar to what you would get with some document databases. And then you also have the option to mix document and relational. So this allows for kind of a flexible, semi-structured data model, that this can still easily evolve with application needs. And I encourage you to check out the documentation on JSON-B to see all the functions and operators. You can add indexes, can be applied, to key value pairs. This will allow for efficient search of keys. But then on the green box there, you can see if you have a highly relational data model with lots of joins, foreign key relationships, you can always use the structure format of rows and columns with the unique data types we just mentioned. But this is unique to Postgres, is that ability to be able to mix the two. You can have a table with some rows and columns and then a JSON-B document for each row that contains attributes of that row, but still allowing flexibility with the data model. So with Cloud Native Postgres, you deploy where you need to, and within Postgres, you design the data model for your application. So there's no need to choose, whether to do document versus non-document because you made a platform decision previously. Right, so another powerful tool within Postgres is foreign data wrappers. So once you've taken a monolithic application and you've broken it down into microservices, or you built a new application, with small services, you might have, say, a login service, a search service, you might have a recommendation service, just depending on the kind of application you're developing. Typically these services would all just communicate through a standard API. But if these services are data intensive, optimizations may be needed on the back end to make this performance. So a service might serve a single business purpose, but it might still include a lot of data. It could be spatial data. You might have millions of users for that one application. You could have inventories with hundreds of millions of rows. In this case, you can efficiently communicate with other data backends that are running Postgres through Postgres foreign data wrappers. This is an extension that's included with Postgres, and therefore it's available on CNP. And just think that if you're running a service endpoint, we're going to cover that in a little bit, that's available with CNP. You can put the service endpoint for the Wright service as your foreign host if you need to use a writable foreign data wrapper, or you can load balance with hot standbys using the host service if you don't plan to write to the remote service. So the CNP architecture gives you flexibility And then there's also the power in the foreign data wrapper capabilities itself, such as join pushdowns. So this executes operations on the remote server instead of pulling all the data back to the local server. This saves on execution and transfer costs. So where clauses, joins referencing the remote server, aggregation, this can all be pushed down to that remote server. So this eliminates that need to pull the data back to the database server, or without foreign data wrappers, pulling data from two different servers down to the application and re-implementing database functionality in your business app. So like we mentioned, what makes the EDB Kubernetes operator unique is that you have, if you have an Oracle background or migrating an application written for Oracle, you can optionally choose to use advanced server. These aren't just catalog views, like all DB user, but these are advanced features like advanced queuing, Pragma autonomous transactions, interval partitioning, hierarchical queries. So you have that option. You can just deploy PostgreSQL. You have the flexibility of the data model. You have the ability to write with a mix of Postgres syntax and Oracle syntax and functions. If you have a lot of data, you can, and you want to put lots of business logic in the database, that's going to be a great option if you have an Oracle developer background. The choice is yours. With Postgres, if your table, if your container has hierarchical data and you want to select rows in a hierarchical order, you can use a recursive CTE. However, you can cut down on the lines of code in your query and use something like the connect by or start with a clause that has Oracle-like syntax. These are advanced options that are available in Advanced Server. So I've seen cases with migration tools that kind of have like a regular expression type interface, reading in the Oracle code and then trying to translate that and rewrite it to Postgres. And you end up with something that's typically like 15 to 20 lines. It doesn't run at execution time. In the case of Advanced Server, something like that's just going to be probably 5 lines, and it's going to execute properly. Autonomous transactions, advanced database features that allow developers to do changes in a separate transaction. You could do a save or discard that's separate, from the main transaction. If you need to mask data returned by a query, then there's the dbms redact package. This provides policies that are applicable to your use case. There's no need to write and maintain this complex logic yourself. However, you have the choice to do that if you'd like to. All right, so hopefully everyone agrees in general that Postgres is a great database platform developers. And if you're on this webinar, you must at least be considering it. But let's get into the deployment specific to Kubernetes and its impact on application development. So Cloud Native Postgres, is a product entirely and exclusively designed for Kubernetes. It's a Kubernetes operator written in Golang, just like Kubernetes, and fully integrated with the Kubernetes API server. It relies solely on Kubernetes to manage high availability. Such, we don't rely on external tools, that were originally intended for traditional contexts. We build immutable application containers for Postgres 10 or higher, and EDB Postgres 10 and higher. And what that means is that, once you hand off your application to develop the DevOps team, that team doesn't need to write their own procedures on how to apply a security patch to the base image or apply a minor update to Postgres. So no more standard operating procedures for those. The operator can perform a rolling restart of the cluster. And this also includes, doing a switch over the primary when the time comes. This is updating the services on the back end. So instead of updating software in place, the operator essentially replaces the container and attaches PG data. This is a big paradigm shift, and as a hardening exercise, we've even gone as far as implementing, the read-only root file system security context for pods. And if you want to develop your application on a production-like environment or need to troubleshoot on a production-like environment, you can do all that even from Docker desktop with software like Kind, Kubernetes, and Docker. So the deployment is exactly the same in that case. And as noted a couple of times, we're planning on releasing the BDR operator later this year. So likely with your application deployments, you might declare that you want 3 web servers and 2 application servers. Since these don't store persistent states, Kubernetes can natively handle the job of ensuring that the actual state meets the desired state. Normally, with a complex application like Postgres, deployment and management would follow an imperative mindset. Create the primary, configure for replication, clone a second one, set it as a replica, clone a third one, set it as a replica. Kubernetes doesn't know Postgres. What we have here is a bit like the instructions for baking a chocolate cake. You drive to the store, buy baking pans, buy flour and cocoa powder, drive home, preheat the oven, and so on until you pull the cake out of the oven. The cloud native Postgres operator is designed for Kubernetes and manages state. So therefore, we define the cluster through a declarative configuration. Using the chocolate cake analogy, we simply order a chocolate cake. For PostgreSQL, we say instances 3, and the operator gives us a Postgres primary with 2 replicas. And this is done at any time. So if you want to update, your desired state, you want to change that from 3 to 2, you can do that at any time. You can jump to 3 to 4 at any time as well. You just post that change to the Kubernetes API server. So if the state of a Postgres cluster changes, say the primary goes down, then the operator performs a switchover and brings back a new standby. We didn't change the desired configuration. Our deployment manifest still says 3 instances. The operator fills the knowledge gap with Kubernetes for how to perform self-healing with a Postgres cluster. This is EDB expertise, integrated right into Kubernetes. You deploy a web server, an application server, and Kubernetes ensures the state of that deployment. Your web and app tier have high availability. If the pod hosting your web app goes down, simply restart a new pod. Now, your database as an application has that same self-healing capabilities with the self-healing from the web front end all the way to the database back end. High availability without the need to, page operations. Go to a Slack channel, pull in, your operations team. All right, so here is a visual. Sorry, take a sip of water there. So we have a desired state of 3. So in our deployment manifest, we have instances 3. And now that we are initializing the cluster, we're first going to bring up a primary. So that's a read-write server. And then we're going to bootstrap a standby server and then bring up our third standby servers. So right now, our desired state meets the actual state. Now, say one of our standby, the pod for a standby dies, the operator is going to jump into action, or the reconcile loop is going to happen. Kubernetes is going to detect that pod is down. The operator is going to jump into action, and it's going to bring up a third standby. So now our desired state meets our actual state. And then if the primary goes down, then the Kubernetes operator is going to know how to handle this situation, promote a standby server, and then a new read replica is going to be brought back up. And it's going to be brought back up because our desired state is still 3. And then, if your application is very heavy with read traffic, then we can just add another read replica. And later on, we'll see how to take advantage of those replicas. And now the desired state is 4 and our actual state is 4. And then we can also scale that down after that read activity has gone. So this might be a known spike in traffic. It's read heavy. We increased the number of replicas, and now we're dropping that to 2. And this is very easy. So this might look similar to your application deployments, right? So the cluster name is myAppDB, instances 3, our container image is 10 GB for the PG data. So this is a very simple configuration, but this would give you a high availability cluster. That's all that would be required. And then kubectl apply is the way in Kubernetes to apply changes to the cluster state. The first command is all it takes to install or update the operator. The second command to install a new cluster using the provided YAML file as a definition of the Postgres cluster type. You can see with the 2 commands how easy it would be to deploy a new cluster in your CI/CD pipeline, or even just on your laptop for local development and take those same steps and perform the deployment in production. So this parallels your own application development, where you package up the entire contents of your application and container and then hand it off to your DevOps team. Deploy the same operator, deploy the database with the same cluster manifest, and then run your application schema deployment. You can even wrap the entire set of steps in a Helm chart. Available in GitHub, you can find our EDB Helm project, if you want to see the Helm charts, and that should provide some pointers for that next step of wrapping your database deployment up with your application. All right, so the ability to deploy on both private and public clouds is becoming a key requirement for new application development. So let's talk about how CMP allows you to deploy anywhere, leveraging that declarative configuration. So I was a database consultant in professional services for many years. And one of the benefits is getting to see, emerging technology patterns. So along with our subscription customers, who tend to be your typical enterprise, I had a chance to work with many born in the cloud companies that were a few years ahead of traditional enterprises in terms of technology adoptions. In a few cases, I work with startups, that built their company from the ground up on microservices. The application was heavily decoupled. The data tier would often be one large monolith, and each application would own a separate database on a single Postgres instance. This would usually be an Amazon RDS instance. And as usage grew, applications were able to easily scale. Just add more copies of your static application and then put them behind a load balancer. But at a certain scale, you outgrow the largest machine instance available by your public cloud provider. And the database is now your bottleneck. This happened to a startup near me in the Boston area. They had scalable microservices. The database on RDS became a bottleneck, along with latency issues based on needing to go into new markets, far away from the app in the database. And then there came the requirement to deploy an application with sensitive data, and this needed to be on premise on their VMware stack in Cambridge, Massachusetts. Obviously, RDS was not an option in this case. And then they also had the need to go into new countries where Azure data centers were closer to those customers. So different customer database was being stored in different Postgres databases, depending on where the customers reside. Some sensitive data was being stored in local data centers where the company had physical control of the servers. Years ago, that would have been, hey, let's get a reference architecture. Let's learn how to do HA management in AWS. Then let's do something separate for VMware. Let's do something separate for Azure. And each environment, there would be these major differences that needed to be accounted for. Well, so these requirements are coming up over and over again. With a standard orchestration platform like Kubernetes, we have a standard way to write code that handles all the operational aspects and then allows you to just simply write an application and wrap that database in your deployment. So we've established, one of the key characteristics of a cloud native application is that it should be able to run anywhere, including on premises. Today, you might have an application requirement to run in your own data center. Tomorrow, the business might need to expand to a separate geographic location with a public cloud provider, with cloud native Postgres. You would be using the same operator and the same container images. And backups are standard Postgres backups that you own in your own storage location. The same configuration will run on any Kubernetes hosted on different cloud platforms. All right, so CMP can deploy anywhere, including pipelines. So this is a real-world EDB example that we use in different contexts. But what I want to show here is the role of Kubernetes in our end-to-end testing. So we spin up Kubernetes clusters, first using Kine, and then in the different Kubernetes distributions, we support and run deeper tests. So, and these tests are run with every combination of database type, Postgres and advanced server, and each database version with each Kubernetes distribution that we support. So the full set of tests are run for every single release. This is a simplified model of that process that the development team uses and has adopted. But you can see, in your own development process, can you use cloud native Postgres to run QA checks? Well, we kind of proved this here that, absolutely you can. You can easily spin up a new Kubernetes cluster using Kind or a managed Kubernetes service, deploy the operator, perform a new database initialization, and then do a schema deployment. Cloud native Postgres has the concept of different bootstrap methods. So your application might have a gold copy, a backup that's stored in an object store. In that case, you could spin up your application, bootstrap a new CNP cluster from a backup, and then run through your application tests using that gold copy. Now that could be taken even further by bootstrapping a new cluster from an existing cluster. No need to run tests on a production or test system. We can do this on the same copy of the data without affecting those running systems by just bootstrapping a new cluster from the running cluster. So CNP can definitely be used in your CI/CD pipelines in a number of different ways. So here's a little bit more information about our automated testing capabilities with CNP. As mentioned, we test all the supported Kubernetes versions, OpenShift, and the public cloud platforms that we support. And we use that with all of the supporting products, Postgres in EDB Postgres Advanced. And these tests are accessible by everyone in EDB from the GitHub repo of our cloud native Postgres. So CNP really provides a database on demand that you can develop locally using your CI/CD pipelines and then hand off to developer operations to deploy using that same exact platform. And part of our cluster deployment, we generate Kubernetes service objects. This is a critical component of the deployment, is intended to be the endpoints your application connects to. So the cloud native Postgres architecture is primary standby. We use the asynchronous by default or synchronous replication if you just update your deployment manifest. So standbys are required for HA. We transparently use PG rewind to ensure consistency among the cluster when performing self-healing operations. But the cluster can be accessed by the applications via 3 Kubernetes services. There's a read-write service, a read service, and a read-only service. These are Kubernetes objects that are created automatically with any CNP database deployment, and these give your application a reliable DNS endpoint. With an HA database running in production for any period of time, you can expect lots of network churn. So this addresses both that issue and provides your application with additional scalability that would have previously involved bringing in new software, having a team to manage it, all just to do load balancing among the existing clusters or existing nodes in your cluster. Right, so here's a visualization of the read-write service. So your application is going to point to the -rw service. So this would be your logical cluster name, and then -rw appended to the end. And that is always going to point to the Postgres primary. If there's a switchover operation, a promotion, then the service object is going to be updated and your application is going to be routed to the correct pod. There are 2 other services that are created. There's a read service that's going to point to both the primaries and the standby servers. And then there's also a read-only service that is only going to point to the Postgres standbys. And these are all updated automatically, just like the read-write service when there's churn in the cluster. So on the top left box, we have our deployment manifest with logical cluster name, PGHA Dolores, and instances 3. So the manifest gives us 1 primary and 2 hot standbys. Once we create the cluster deployment by posting our manifest to the Kubernetes API server, as we can see in the green box, then we get 4 services that are created automatically. So no matter what happens in our cluster, the services will always route to the appropriate Kubernetes pods. So in terms of architecture, it's probably early to understand all of the possible use cases, but I mean, you can easily see the 2 main use cases, inside Kubernetes or outside Kubernetes. So the first use case is going to be your best experience. And thanks to the infrastructure abstraction, this creates an end-to-end highway between the developer and the end user of the application. It removes the variability between development, staging, and production environments, and additionally enables the CI/CD pipelines at the application level. Technically, the stateless application is managed as a deployment with an underlying replica set and is exposed externally through an ingress. The database is managed by the operator, which exposes a service to the applications, as we showed in the previous slides. And the second use case, the application resides outside of the Kubernetes cluster. These might be legacy applications or applications that are in the process of being containerized. The application is hosted on traditional environments, and then the database is exposed externally through TCP and TLS through an ingress. While one architecture is more desirable than the other, we've worked with customers doing both. Hey, we're shifting to a public cloud, and you know what, we're going to just look at Kubernetes for the database. We don't want to go through all the other validation for the database platform. Right. And this diagram provides a more detailed view of the components. The stateless application can easily scale up and down with the instance parameter, or even automatically, depending on the external workload. You can run custom applications in pods managed by deployment through a replica set. This enables canary deployments, rolling updates, self-healing, high availability. The pods can run containers that includes the applications, written by your preferred technology stack. They're in the third bullet. The stateful components, rely on Postgres pods managed directly by our cluster custom resource with CMP. The operator performs cluster management, and applications talk to the database via Kubernetes service. And the operator enables some of those self-healing capabilities that we found in the stateless applications. So this allows those same advanced operations for a stateful application, which in our case is going to be Postgres. So how do you connect to those services? It's fairly straightforward. So here's a simple example of a const block in Golang. This would be similar in other applications, such as a JDBC connection. For JDBC, be a URL, JDBC, :PostgreSQL, ://, then the service name, / and the database name. So our host is the service endpoint. Our username, password, and database can all be managed as part of the application deployment. Again, no need for a ticket with a DBA team. Using the Bootstrap framework in CMP, we can provide a database, an owner, Dolores in the example on the slide. And then we can also provide the password, and we provide that as a Kubernetes secret that's referenced in our deployment manifest. So when the Postgres cluster is initialized, the database is created with the owner provided, and the password is set to the secret value. All you need to do is connect to the database using those credentials and start with your application schema deployment. On the right-hand side, you would have a read-only service, and then you would have your read-only user connecting to that service. So if you know in your app where the database reads are being performed, then you'd simply use a connection class with that read-only service. And you use the read-write service where your application performs database writes. So there are advanced features of PostgreSQL that were typically reserved for companies that staff with Postgres expertise. So run through these real quick. The point here is that these are advanced features in Postgres that can just be part of your deployment manifest. So the PGHBA settings, spec property of the cluster. If you know which endpoints need to talk to your database server, then you can restrict communication. As part of CMP, we also try to make TLS certificate authentication easier to use in a traditional context. Setup can be quite cumbersome. But as part of a deployment, we create a certificate authority, use SSL communication for Postgres to Postgres communication, and for the API server, and we do that out of the box. We also provide a kubectl plugin. You can find that on GitHub, and that can be used to issue a TLS client certificate that applications then use for database authentication. This is a valid and trusted certificate and can be used instead of having to manage other passwords and secrets. So, if you're deploying hundreds of microservices, this is a plugin for kubectl, not a separate tool, and really helps kind of reduce the amount of passwords that you have to manage. By default, all replicas are configured with asynchronous stream replication, but you can determine if that fits the use case for your application. Some applications, could lose a few seconds of transactions that are in flight, being lost, if a Postgres node crashes. If your application needs to ensure that if a commit message was received, that it is available on the standby, so no lost in-flight transactions, that had received a commit message to the application, then you can configure streaming replication with synchronous very easily. You just use those two parameters. You can look up the Postgres documentation to see the values that are appropriate for you. And you can see in here our PostgreSQL configuration. One common scenario we see is with work mem parameters, table size grows, new queries get added. It's not uncommon to see queries start spilling over to disk, large sorts, hash tables. Just using this work mem scenario, you run an explain plan, see an external disk merge. You can simply update the deployment manifest and set work mem at the Postgres cluster level. So one of the nice things about having the parameter updated in the deployment manifest is that it's self-documented. You can even ensure, all changes are pushed to a central repository and apply the manifest, over an HTTPS connection, that's links to your code repository. The operator automatically detects which version of Postgres you're running, including EDB Postgres Advanced. So all you need to do is point to an official EDB Postgres Advanced image. By default, the cluster will be created with Oracle compatibility enabled. Now, all of the Oracle compatibility features we talked about earlier are now available to you. So that's it. So you can see how easy it would be to have a mix of PostgreSQL and advanced server and use the same deployment patterns, same operation patterns, using the same operator. And real quick here, so cloud native BDR. So, you might have different applications that have different requirements. So BDR can be used for when you want to have any of the nodes in a cluster be able to accept writes. So this implements the write anywhere architecture with BDR 3.7. This is multi-master replication. So we'll have that available later in the year. And the connection services are going to be slightly different here. Obviously, any of the nodes, but we can always route traffic to the lead master. So in this case, the use case is similar to Postgres, but failover and switchover are going to be almost instantaneous. There's no promotion of a standby that's involved. You can do more of a round robin, randomly distributing load over the ready masters. So again, this will be available later in the year. So you can, pick which one, primary standby architecture or BDR, whichever operator is appropriate for your application. All right, so just go through the recommended next steps here. So all of the features available in Cloud Native Postgres are covered in the documentation. How to connect to Postgres, a Postgres instance that's deployed with the operator is covered in the documentation. So if you want to hurry up, get your hands dirty, there's no quicker way than just going over the docs, because you can go there and you can use the interactive demo. So you can deploy the operator, deploy a database cluster from your web browser. And then when you're ready to start, any local application development, you could use those same steps, even just on Docker desktop using Kind, or you can use a managed Kubernetes service and get started really quickly. So our software, can be, evaluated by anyone. So you can, with the operator, will deploy PostgreSQL and has an implicit 30-day trial. Nothing happens to your databases at that point. The operator just stops reconciling the cluster. With EDB Postgres Advanced, license keys required to start. It's all you need to do is request a trial for the EDB website, and this lasts 60 days from the day that the license is issued.
Thanks to Adam for the session. We have Chandan with us, who will help us with the Q&A session. Hi, Chandan.
Hey, Kapil.
Thanks for your support. So we have a few questions for you. First question is, how does Postgres handle major version upgrades?
Okay. So as of now, the operator supports only the minor version upgrades in a rolling fashion. But later this year, we have plans for the major version upgrades in a rolling fashion as well. So I guess that answers the question, right? So it is more towards how do we handle major version upgrades. So currently it is not there. It is only there for the minor version, but we are also focusing on major version upgrades in a rolling fashion. But if downtime is required, certainly you can go with the major version upgrades with the downtime.
Okay. Next question is, what are the Kubernetes services for application from EDB Kubernetes offering?
Okay. So the current operator supports read-write, read-only, and read connection. So you can use this ready-made services to be used by your application wherever the load is required, as in terms of maybe if the load requires a read-write, excuse me, then you can point the services to use the read-write, similarly for read-only and for the read connections.
Okay. How backups are taken?
Okay, so when it comes to backups, we use the Barman, but not the native Barman. It is the Barman cloud backup tools we are focused on. It is much more enhanced, and we use these tools as well as for the archives. We use Barman Cloud Wall Archives.
Okay. What are the replication modes support at DB?
Okay, so we support the same native replication modes, which are asynchronous and synchronous mode. Both can be used. So we have the operator made in a such a way that it understands both the synchronous mode and asynchronous mode. So even if a pod dies off, then it acquires the same state of replication what was initially kept in the manifest file. So both the modes are supported, asynchronous and synchronous.
Okay. I think we have time for one last question.
Sure.
Uh, how high availability is achieved in cloud native Postgres?
So we do not rely on any of the third-party tools. So it is handled automatically by the operator itself. So we have used the cloud native principles in order to get it achieved. So basically, we do not have any dependencies on any third-party tools. It is done automatically.
Okay. Uh, Thank you, Chandan, very much for your support. I apologize for all those questions that we were not able to get to today, but that's all the time we have. Thank you all for joining us for the webinar. We'll be sharing the recording along with the slides with you as soon as possible. I hope you have a great rest of your day. Thank you.